Hello again, guys. So at the end of the last video, I gave you this exercise. So you should do this before watching the answer. Uh, and if you are stuck, if you couldn't do it, then why don't you just watch the last video and do what I do with different numbers? That's the biggest advantage of online learning. So if you, of course, it's complicated. You cannot do this at the first time, but you can just follow what I do as a practice. Then you will get used to it. That's how you learn. So please just don't give up the exercise just because you don't know how to do that. You can watch the video again and just imitate what I do and try to uh, do what I do. It's easy on YouTube. And exactly same structure. There are four numbers, and you may just do how I calculated the variance. And let's do this. The first step was to calculate the mean, which is easy, or you can just add four numbers, divide by 4. And then using the mean, subtract the mean from each observation. 73 minus 75 is minus 2, which is the deviation for spring. And 95 minus 75 is plus 20, which is the deviation for summer. And 77 minus 75 is the deviation for fall. And 55 minus 75 is the deviation for winter. So you have 4 deviations from each observation, and then square them. Take squares. 2 squared equals 4. 20 squared equals 400. Of course, they're the same. And finally, add what we are doing is we have to calculate the average of these 4 squared deviations. To calculate the average of the square deviations, sum those 4 numbers and you divide it by 3, 4 minus 1, because we are using the sample variance. We are calculating the sample variance, so the denominator must be 3. Then your variance is 269.33. So now we can compare the sample variance in Phoenix and to the sample variance in Honolulu. Honolulu's sample variance was 13, and Phoenix is 269, and many times much larger than Honolulu, which is exactly what we expected. So Phoenix temperature varies much more than Honolulu's temperature, so that's why the variance is much larger in Phoenix than Honolulu, right? So this is how you calculate the sample variance. If you were to calculate the population variance, you may just replace it with 4 for the sample size. If you use sample size, then the number will be different. Then when you use the population variance, of course, you have to compare the population variance from Phoenix to the population variance from Honolulu. So when you match the formulas, you may compare them, right? Okay, we learned how to calculate the variance when you have raw data. Like in this example, you have 4 observations. When you have more observations, the steps are the same, the idea is the same. And the next topic is to calculate the variance when you have a probability distribution table. This kind of contrast structure, the difference between raw data and probability table, is the same structure as in the mean and the median. So you should have expected this. Now we are going to consider another example. It is suppose that there is a financial asset whose returns is very simple. And there is a, you may lose $10 with 20%, and you gain nothing but lose nothing with 40%. And if you're lucky, you gain $20 with 40%. You may think it as a gamble, or you may think it as a investment. Doesn't matter. So let's calculate this investment variance, or it's about the risk of this investment. So we are calculating the variance. Uh, by the way, remember that the idea is the same. We are going to calculate the deviation, and we are going to square that. We are going to calculate the square deviations, and then we are going to calculate the average of square deviations, because the variance is the average squared deviation, right? We are doing the same thing from different uh, data format. So think about this. First, you have to calculate the mean and multiply the outcome to the probability and obtain the probability weighted outcomes and sum the probability weighted outcomes. The mean is 6. So on average, you get $6 from this investment. Now the next step is, because now you know the mean, you can calculate the deviation. So when you lose $10, by the way, I change it probability to decimals. It's natural. 20% becomes 0.2, 40% becomes 0.4, so that the algebra becomes easy. And using the mean was 6, subtract the mean from the outcomes. So if you lose $10, that is $16 below the average, $16 below the expected return. So minus 16 is the deviation. And even if you lose nothing, still it is $6 below the expected return. So from your expectation, it loses $6. It's lower than your expectation. But $20, if you gain $20, it's $14 above the average, right? So the deviations are minus 16, minus 6, plus 14. Then the next step is to calculate the squared deviations. And you may use calculator. The square of minus 16 equals 256. Square of minus 6 equals 36. 14 squared equals 196. So what we need is these guys. Square deviations is the main objects we need to calculate the variance. These are the distance from the center. And because this is the new random variable we are interested in, I may delete all the other columns, but the probability. Remember, in the previous chapter, we learned how to transform a random variable and how to calculate the mean of the transformed random variable. You have to make a probability distribution table for the new transformed random variable. In this example, in this case, a square deviation is a new random variable. So we do the same thing, put the same probabilities for the new random variable. And then now you can calculate the mean using this table. It's easy. Just treat these as a new outcome, a new random variable. Then outcome times probability is the probability weighted outcome. 51.2 is the probability weighted outcome for the first one. And 36 times 0.4 equals 14.4. And 196 times 0.4 equals 196 times 0.4 equals 78.4. So this is exactly what we did to calculate the mean. We are calculating the probability weighted outcomes and sum. sum these three numbers, you get 144. That is the variance, right? The only difference is the idea is the same. We calculate the mean, we calculate the deviations, we calculate the squared deviations, and then calculate the mean of the squared deviations. But when you calculate the mean at the first step and in the last step, you have to adjust, you have to use the probabilities to calculate the weighted outcomes. That's the only difference, which is the same difference I explained in the previous chapter. When you calculate the mean, there is a difference between the raw data method and the probability distribution table method. If you understand that, it should be natural. So in sum, we do this, calculate the sum of probability weighted outcomes. I put probability weighted outcomes to show that you have to use the probabilities. And the second, third steps are the same. Subtract the mean from the observation and square each of the deviations. And then 4 is the difference. When you have raw data, there is no probability. So you could just sum the square deviations and divide by n or n minus 1. But now you have to use the probabilities and sum the probability weighted square deviations. So this is the first step, and the last two steps are different from the previous method. It's typo. So sorry about this. It's how to calculate the variance when you have a probability distribution table. By the way, there is no difference between population and sample variance formulas in this case, because the weight is automatically determined by the probabilities. So you don't need to worry about dividing by n or n minus 1. So once you have probability, so there is no difference. And use this method to calculate the variance of this new table. Now, what the scenario is, suppose that to do this investment, you have to pay $1 as a fee. So like tax or kind of commission or like registration fee, whatever, or admission to a gamble site. Anyhow, so you have to pay $1 upfront. So when you lose $10, actually you are losing $11. When you gain $20, actually you gain only $19. So probabilities are the same. I just took $1 off from the previous gain and loss. In this case, what is the variance? And there is no difference between sample and population. So I just said the variance. Try this, and as I said, I recommend you to watch the video again and put a paper and follow what I did with the previous example and the change. Try the same thing with these different numbers. You get different numbers and just repeat. Do the same thing I did in this video to get the answer. Pause the video here and I will show the answer now. The answer is, like before calculating the variance, we have to calculate the mean. Mean is 5. The idea is the same. We have different outcomes, but same probability. So multiply them. Then you get these numbers, which are different from the previous numbers. And if you sum them, you get $5. So now the expected return is $5. Remember, in the previous example, the expected return was $6. Now it is $5 because you paid $1. $1 is taken off from your return. So the mean decreases exactly by $1, as much as the fee. Anyhow, you get the mean at $5. So $5 comparing the outcomes to the mean, you get deviations. What is interesting is that the deviations are the same as the original example because I took out $1 from the outcomes and also $1 was taken out from the mean. So it's just another parallel shift. I changed everything by -1. So the distance does not change. Mean decreases by 1 and outcome also decreases by 1. So the distance itself does not change. So deviations and the square deviations are the same. Of course, probabilities are the same. So there is no difference. It's identical table as before. So if you get to this point, you don't need to do this math again. Algebra is of course the same. All the numbers are the same. I just copied and pasted. So the new variance is 144. That's the variance after the phi, and we will think about why they are the same in the next week. I'm going to stop this video here, and today we learned how to calculate the variance, and it is quite complicated. So please do the exercise and repeat the exercises. Try them again if you are not confident. It could be very confusing when you actually do it by yourself. But try them and make yourself more familiar with them so that in next week we are going to study some properties of the variance, and then I'm going to introduce the standard deviation. And also there will be more topics, but it's important to understand how you calculate the variance. So make sure you know that. Okay, thank you for watching the videos and have a nice weekend. See you next week.